Lesson 19 continues on to page 2, or to day 2 on page 7. Once again, day 2, which is on page 7. I'm going to start with the entry task, and I only want to do like a couple of these. I'll do A and I'll do C, only because I figure this one's going to be challenging, this one's going to be challenging, and then you can do B as a practice. A, when we're going to describe the domain of a function, we're talking about possible x values. So if I go to this point, then in order to get to this point on the x-axis, I have to go over to 1 and then go up. So 1 is a member of the domain. To get to the second point, I have to go over to 3 and then go up. So 3 is another member of the domain. And that means 4 and 6 are the other two. There's only 1, 2, 3, 4 points. To finalize your response for the domain when you're trying to list a set of objects or a collection of objects, we use these little curly Q brackets. And a lot of people say, I can't make those, and so neither can I. The domain, the set of all possible x values. Domain, the collection, the set of all possible x values. So I'm going to do part C as I change my discussion from A to this question. In order to help answer the question, I'm going to eliminate possibilities. Like I'm going to eliminate -6, I'm going to eliminate -7 and -8. Can you tell why? I mean, why is because if I go up or down from these values, we don't cross the graph. Same is true of 7, of 8, of 9. If you go up or down from 7 or 8 or 9, you don't touch the graph at all. And the domain describes all possible x values. Like this point right here. It starts the curviness of the function. It has an x-coordinate of -5. And then -4 works, -3, -2, -1, 0, 1, 2, 3, 4, 5. In fact, up to 6. So I'm going to use the less than or equal to sign. It's a filled in circle, so less than or equal to. Use the letter x, but this open circle does not get equal to. Here's our domain. This moves into the next example. What is a discrete function? Discrete means that all values are separate or distinct, that there are gaps. Continuous has the flip of that. Continuous means that no point is separated from the nearest one, from the next closest one. There's a calculus explanation for this. Later on we can talk about it then when you get there. No point is separated from the next closest one. Literally, don't pick up the pencil. For our diagram, I mean, discrete has like the idea of a sequence. The points of a sequence are discrete because there's not meant to be any connecting lines. There's meant to be gaps all the way along. Continuous means that you would have even the same picture, but you would have a line that connects the two. In the real world, or in a context of trying to talk real world, let's take a look at tickets to get into a museum. By the way, go sometime. It'll make you feel better. Is the domain of this problem discrete or continuous? Well, the function compares cost, so that's money, to tickets. So tickets, I'm going to add this to the problem. It's going to compare the cost for tickets. This is a discrete scenario, right? You can buy 1 ticket or 2 or 3 or 4. You will not buy no tickets and then walk up to the counter and say like, hey, no tickets please. That's dumb. And then you don't buy -1 tickets because that doesn't work either. So we're talking about really the set of all positive, you want to say real numbers here, but these are not, like fractions are not allowed. No fractions. No negatives. So it's all positive integers. Because it's all positive integers, the domain of this problem is discrete.